So, I'm going to repeat myself a little bit. This is a compound machine, and it means it has. These are all simple machines, by the way. All these are simple machines, and a compound machine has two or more of these. And so I just gave you an example right here of here's one machine where there's gears, and this one is a 12 tooth gear, a little one, and a 36 teeth gear here. And this is my input. I'm going to twist this, I'm going to rotate this gear here, which will rotate this bigger one a little slower, which means it's going to rotate stronger. Slower, but stronger, so you're going to get more torque. So this is one machine. Then the string is around this pulley, and when you twist this one rolls, and it starts to wrap this string around this shaft, and it goes around this pulley. Pulleys are always an IMA of 1. Okay? If it's just a simple pulley with a string around it. Okay? There's other pulley systems like block and tackles that do have different IMAs, but this one's just going to be a 1-to-1 ratio. So we'll just say it has an IMA of 1. That's our second machine. Our third machine is this, and I need to know some information. So here's where the a point of attachment is. So I need to know this. This is the distance of my distance of effort, right? Because think about it. We are pulling on this. Well, technically the string is, which is getting pulled by this, which is getting pulled by me. So the input is over here. So this is the distance of effort, and we'll say that that distance of effort, that's a D there. Distance of effort, let's say that's 3 inches. And then we're going to go here, and this one is the distance of the resistance, and let's say that that's equal to we'll say that's 12 inches. And so for this one, by the way, I'm going to back up a little bit. For this one, the IMA is 3. That's for this one here, the gears. All we do is take the number of teeth on the output wheel and divide by the number of teeth on the input wheel, and we divide it. Then the IMA of the pulley is always 1 because it's just a simple pulley. And then now that brings us to this one here. What is the IMA of this one? If you remember, it ends up being dr divided by de. Oh no, sorry, I'm wrong. It's the opposite of that. So we're actually going to lose we're going to lose a little bit of mechanical advantage because I'm pulling on the little side and lifting the longer side. So I just got a little bit backwards there. So dr divided by de, and that's 12 divided by 3, right? So here's dr divided by d3, and distance of resistance. Wait, no, I was right the first time. What did I do wrong again? I think I did that twice the same. Distance effort divided by distance resistance. This is the correct equation, okay? That is the correct equation. And that's equal to the effort is 3 inches divided by 12 inches. There we go. I got my head on straight now. And that's only going to be, what is that, 1/4? It's like 0.25. Yeah. So 0.25 or 1/4. You can also say 0.25 is the IMA. I'm fine with that. So now we have 3, 0.25, we have 1, and we have one more here. This one's the inclined plane. And for that one, oh, I don't know how did I do that? I got a line. I've been always trying to figure out how to make a line, and it just made one. Nice straight line. I'll figure that out later. So here we go. I need to know this distance right here, and this is definitely the distance of my effort. And this one right here is this distance right here is right there is the distance of the resistance. And let's say that's 3 inches high, and that this is let's say 30 inches. And IMA of an inclined plane is equal to distance of effort divided by distance of resistance, just like it is here. And we take 30 inches divided by 3, and it's equal to 10. Okay? Now, what is the IMA of this whole big old thing? It's actually quite easy. You just take the IMA total is going to equal to the IMA of all of them times each other. So what do we got? We got a 3 times a 1 times, what's the next one? A 0.25 times a 10. This one right here. And so the total IMA is, I'm going to need a calculator for this one. And it is 3 times 1 times 0.25 times 10. 7.5. That is the total IMA of this big old compound machine that's all complex and got all kinds of stuff going on in it. So I want you to design your own, plan it out on a piece of paper. In class, we would actually physically build it. We have all kinds of cool metal and stuff, and you'd make it. But today, we're just going to design it. And maybe we can try to make it later with those little plastic pieces. I don't think there's enough. Depends what you're making. But you're gonna design one for me with 2, 3, 4 simple machines, and then do the math. Just make sure you're not doing exactly the same numbers I have. You're even welcome to attempt the same one that I did. But the problem is I just want you to make sure you're using different teeth numbers if you're going to use the same gear system. The IMA is always going to be 1 if you're using a pulley, where the string goes around a little pulley, a little round wheel, to redirect it. If you're using a lever, make sure you use different DE and a different DR. And same thing with an inclined plane, use a different DE and a different DR, okay? And that way in the end, your work's a little bit different and you'll end up with a different IMA, but it's all theoretical. We're just going to have you work it out and see if you guys can just run through the problem. So draw it out. I want to see your picture. I want to see your work. That's it, okay? I want to see your picture and your work.